Welcome to Chapter 7. In Chapter 7, we're going to be looking at exponents. In today's lesson, 7.1, we're going to be looking at 0 and negative exponents. As a warm-up, I want you to, in the first three problems, circle the exponent in each of those equations. For numbers 4 and 5, I want you to write an equivalent expression using an exponent. And finally, in number 6, I want you to identify the base and the exponent. So let's see how you did. The exponent, remember, is the little number up in the upper right-hand corner here. So the 5, the 2, and the 7 are the exponents here. Writing equivalent expressions using an exponent, this number here is repeated 3 times. So you write 35 to the third power. The 19 is repeated 9 times, so it's 19 to the 9th power. And finally, in the last one, 4 is the base and 3 is the exponent. So, just reviewing a couple of things. In 5 to the third, the base is the 5. The base is used as a factor as many times as given by the exponent, which in this case is 3. So that means 5 to the third is equal to 5 times 5 times 5. In 5 to the third, the exponent is 3. The exponent tells how many times the base 5 is used as a factor. That is, 5 to the third, again, is equal to 5 times 5 times 5. And a power is a number that's written using an exponent. So, when we look at this, we use exponents to write multiplication expressions that have factors that are repeated. So again, the 2 is the base, the 3 is the exponent. The exponent tells how many times to use the base as a factor, and the base is used as the factor. So this does not mean 2 times 3, it means 2 times 2 times 2 3 times. 2 times 2 is 4, 4 times 2 is 8. To write in exponential form, you're going to count how many times the base is a factor, and then you're going to write the base and use that count for the exponent. So, for example, here I have 4 times 4 times 4 times 4 times 4. Well, since the 4 is repeated, that's the base, and it's repeated 5 times, so that means it's the 5 is the exponent. Let's practice. I want you to rewrite each of these expressions using exponents. Let's see how you did. In the first one, we have 3 repeated over and over and over again, so that would be 3 to the 4th power. Here we have y repeated 5 times, so that's y to the 5th power. X repeated 3 times, so that's x to the 3rd. And here we have negative 3 in parentheses repeated 5 times, so that would be the quantity negative 3 to the 5th power. Now let's go the other direction. Here's the expression. You need to write it out as multiplication. So for the first one, you should have written out 4 5s with multiplication signs in between, 8 b's with multiplication in between, 3 7s with multiplication signs in between, and 5 m's with multiplication signs in between. Now, our vocabulary word for today is negative. So a negative quantity has a value that's less than 0. For example, negative 3, negative 1/2, and negative pi would all be negative numbers. You might ask yourself why negative is our vocabulary word for today when we've been working with it all year. Well, again, keep in mind, in this section we're going to be looking at negative exponents. So, what I want you to do is I want you to do these expressions and see what you notice when you get down here to see 0 and the negative exponents. Starting off here, 2 to the 4th means 2 times 2 times 2 times 2, which is 16. 2 to the 3rd means 2 times 2 times 2, which is 8. 2 to the 2nd means 2 times 2, which is 4. And 2 to the 1st, which is just 2. Now you'll notice in these numbers that to get from 16 to 8 we divided by 2, to get from 8 to 4 we divided by 2, to get from 4 to 2 we divided by 2. Now the pattern has to keep going, so I'd have to take 2 divided by 2 to get my next number, which is 1, 1 divided by 2 to get my next number, which is 1/2, 1/2 divided by 2 to get the next one, which is 1/4, and 1/4 divided by 2, which is 1/8. Now do you notice anything in particular about these numbers here? You should notice that 2 to the negative first is the reciprocal of 2 to the first. 2 to the negative second is the reciprocal of 2 to the positive second. And 2 to the negative third is the reciprocal of 2 to the third. This pattern would continue on for 2 to the negative 4th, negative 5th, and so on. So, the property that we've just looked at is the zero exponent property. So for every non-zero number a, any number a, except for 0, to the 0 power is going to equal 1. Negative exponents, for every non-zero number a and integer n, if you have a to the negative n, it's the reciprocal. You take that a to the n to the bottom, making the n positive. Let's try some examples. 6 to the 0 would equal 1, so what would negative 24 to the 0 equal? That would equal 1. 7 to the negative third is going to be 1 over 7 to the third, and 7 times 7 times 7 is 343, so 1 over 343. 4 to the negative second would be 1 over 4 squared, which is 1 over 16. And negative 3 to the negative fifth power would be 1 over negative 3 to the positive fifth power. Notice in this last example that the only thing that changed its sign is the exponent when you move it to the bottom. And negative 3 times negative 3 times negative 3 times negative 3 5 times would give us negative 243. True or false? Look at each of these and decide whether you think it's true or false. Let's see how you did. 9 to the negative second is 1 over 81. That is true. 9 to the negative 1 is negative 1/9. That is false. Negative 9 to the 0 equals negative 1. That is false. Anything to the 0 power, remember, is positive 1. And 9 to the negative third is 1 over 27. That is true. So, homework problems tonight are going to look like these. You're going to be asked the simplified form of 4 to the negative third power. So, complete the steps. 4 to the negative third. First thing you're going to do is move the power to the denominator and make the exponent positive. Then you're going to evaluate the power to simplify the expression. So the negative 3 moves to the denominator and becomes 4 to the positive 3. And then 4 times 4 times 4 is equal to 64. Let's try some of these. Negative 1/2 to the 0, negative 5 to the negative 4, positive 5 halves to the negative 3, and 1 over 6 to the negative 2. Well, anything to the 0 power is going to equal 1, so this is equal to 1. This goes to the bottom, but becomes a positive 4 as the exponent. Negative 5 times negative 5 times negative 5 times negative 5 is positive 625. In this one, the negative exponent's actually going to move the 2 to the top and the 5 to the bottom. Then it's going to be 2 to the third, 5 to the third. So that's going to actually give us 8 over 125. This one, since the negative is in the bottom already, the reciprocal would be take it to the top. So 6 to the second is equal to 36. Again, looking at some simplifying expressions here, 4 to the negative 1 would just be 1 over 4. 1.02 to the 0 power, anything to the 0 power is equal to 1. 1.5 to the negative 2 is going to go to the bottom and become 1.5 to the positive 2, and that's going to be 1 over 2.25. Negative 2 to the negative fifth is going to be 1 over negative 2 to the positive fifth, and that's going to give us 1 over negative 32. Your homework assignment tonight is on page 417, numbers 9 through 20.